So I had linear and quadratic models. A linear model is the general equation of a straight line, and the equation for that is y equals mx plus c, where m is the gradient or the slope, and then c is the y-intercept. And then this is an example of what a linear model looks like. As you can see, it's a straight line. And then a quadratic function is an expression which the highest variable exponent is 2, and the equation is f of x equals ax squared plus bx plus c, and a does not equal 0. And this is an example of what a quadratic function looks like. As you can see, it makes a parabola. If a is positive, then the function has a minimum point, and if a is negative, then the function has a maximum point. We can remember this by saying when you're positive, you smile, so it makes like a U, which has a minimum. And then when you are like feeling down, you're like negative, so you like make a frown, and that makes a maximum point. In this, we also have a line of symmetry, and it cuts the curve of the parabola in half, and the turning point is called the vertex. The line of symmetry, the equation for the line of symmetry is negative b over 2a. And this is an example pointing out of what each one is inside of a quadratic function. So the vertex in this case would be the minimum, and then the line of symmetry is the line going down the middle. So the quadratic function f of x equals ax squared plus bx plus c. It'll always have one y-intercept. The y-intercept is the value of f of x when x equals 0. So if x equals 0 and y is 2, then the y-intercept is 2. In x-intercepts, there can be many situations, such as multiple roots, one root, or no roots at all. We also have exponential functions and polynomial functions. An exponential function is a function where the output value is multiplied by a fixed amount for each unit of increase in the input value. So in this example, we have exponential growth. The general form for this is f of x equals k a to the x plus c. And then if you have decay, which is like declining, then the general form is f of x equals k a to the negative x plus c. And with this, we also have asymptotes. So exponential graphs level off a particular value, which it gets close to but never actually reaches. So that's what an asymptote is. And the equation of an asymptote is y equals c. So this is an example. It says draw the following functions on your graphing calculator and find the equation of the asymptote. So if the equation of an asymptote is y equals c, then for a, the equation given to us is f of x equals 3 to the x. And as you can see, c is 0 because there's nothing written there, so then the asymptote would just be 0. Where's the equation? And then the next equation is 3 to the x minus 4, and this is c, and so that would just be the asymptote because y equals c. So the asymptote for this one is negative 4, and that's your answer to B. Can we like just edit this together?
Yeah, do you have to edit?
I can, it doesn't matter. Dude, I'm dumb. It literally says the equation of an asymptote is y equals c, and that's why that one is 0, because we went through all of that.
You're such a head.
I'm so dumb. Okay, where are we starting? We can end that. Okay, can you start? Wait, how many minutes was that? The next example says the population of a town is growing, and the equation for this is P equals 48,000 times 1.02 to the T. So I'm going to write that. and then we have to calculate the population after 5 years. So in this problem, t is time, so we would just put in 5 for t. So it would be 48,000 times 1.02 to the 5th power. And then when you plug that into the calculator, you get 52,995.87855. But in this case, we can't have like half a person or part of a person, so we would round up. So the final answer would be 52,996. And then in the second part, it says find how long it will take for the population to reach 60,000. So we would in this case, 60,000 is our final population, so that would be P. So it'd be written like that, and in this case we have to find what T is. So we could do that by dividing by 48,000. You can pause that. So in this case, we would put 60,000 into y1 in our calculator, and then 48,000 times 1.02 to the t in y2 in our calculator. And then when we graph it, it would show the graph, and then you would find the intersection, and the answer would be 11.3 years. So that would be the answer for B. And then C, it says find how long it will take for the population to double. So if originally the population was at 48,000, then when the population is doubled, the total would be 96,000. So we have to find how long it will take for it to reach 96,000. In this case, you would do the same thing with 96,000 y1 and 48,000 times 1.02 to the x in y2. And then when you find the intersection, the answer should be 35 years. So it would take 35 years for the population to double from 48,000 to 96,000. Polynomial functions are made up of powers of the independent variable. For each degree of a polynomial, there are a maximum number of turning points. So for example, if you have a linear function, the general formula would be f of x equals ax plus b or ax plus c, and the degree for that is 1, and so the turning points would be 0. If you have a quadratic function, the degree would be 2 and then the maximum turning points would be 1. If you have a cubic function, then the degree would be 3 and the maximum turning points would be 2. And if you have a quantic function, then the degree would be 4 and the maximum turning points would be 3. And if you have a quintic function, then the degree would be 5 and the maximum turning points would be 4. So we're going to sketch this into the So in this, we would put this into y1, 2x plus 3 over x plus 4. It's asking to sketch the graph of the function. So 2x. And then we'd have to change our window from the x min to be negative 10 and the x max to be 10. Yeah. So in this problem it says sketch the graph of the function f of x equals 2x plus 3 over x plus 4 for negative 10 is less than or equal to x, which is less than or equal to 10. So when you sketch this out, or when you put this in y equals in the graph, it should look like, if this is your graph, it should look like this. Like that. And then write down the equation of the vertical asymptote. So that is just your y equals c. So the answer to that would be negative 4. And then number 3, it says sketch the graph of g of x equals x plus 0.5. So x. In that case, it would just be a straight line. So it would go like that. That is g of x. And then we have to write down the coordinates of the intersection. So it'd be like right here. So you go second trace, intersect, first curve, and then the second curve. So your x should be negative 1.5 and your y should be negative 1. And then write the gradient of the line g of x equals x plus 0.5. So for this, you would do the slope equation, which is y2 over y1 equals x2. Wait, y2 minus y1 over x2 minus x1. And so for this, your gradient should be 1 because it's 0.5 over . Yeah, because when you have negative 1.5 minus negative 1, you get negative 0.5. So, and then your other coordinates would also equal negative 0.5, and that equals 1, so that would be your n. This is another example. It says sketch the following and find the y-intercept. So you would plug these two equations into y1 and y2, and when you do that, it's sketching right now. But we can go ahead and find the y-intercept. So the y-intercept is whenever x equals 0. So in this case, we could always go to table, so that'd be second graph. And then for y1, that's this first equation. When x is 0, y equals 6. So your y-intercept would be 6. And then for b, when x equals 0, your y-intercept is negative 4. So that would just be negative 4. And then when you sketch it out, it should look, if this is your graph, it should look something like this. Should look something like that. And this is your homework. It would be complete the mixed examination practice, odd numbers only. So just do that, I guess. You can stop it.